Yeah, I'm Bill Kaufmann from Blue Planet, and realizing the network digital twin will focus on some of the experiences we've had in developing the digital twin, as well as some kind of forward-looking views on what's coming next. And if I click ahead here, which is probably this one, there we go. So why network digital twin? What is a network digital twin, right? That's a very tricky question because everyone I talk to seems to have a somewhat different view of what they want to get out of a digital twin and what that's supposed to achieve for them. In our developments, we focused on kind of multi-layer transport and IP networking, but of course, you can expand to other areas as well beyond that. To create a digital twin, the first step is to replicate your current network in a virtualized environment, and that becomes then the twin of your physical network. And with that, the first step would be just, can I replicate the current state of the network? With that, I have a great troubleshooting tool. I can understand why a service might be down. I can understand where congestion exists in my network, all this great information. Do I have enough ECMP routes in my network to provide resiliency for my customer services? So that would be the first step, is to kind of create that real-time observability tool. But to go beyond that then, and I think this is more what people think of when they think of a digital twin, is not I want to kind of replicate that virtualization a second time, and I want to be able to manipulate that view of the network. So I have a current view, and then I also have this sort of sandbox view of the network where I can add more core nodes. I can validate the investments I'm making to understand, if I add more core links in my network, if I add more routers. There was a lot of talk this morning about network simplification. Maybe before you actually roll out the simplification strategies, you want to test it and validate that you're going to get the expected end results. So that's sort of a future state you're looking at of the digital twin. But we also have the past state, right? IP networks are ephemeral, they change. The network that you had yesterday might be different today, and you might not be able to replicate that past view. You might not even be able to access the data that existed yesterday to understand why a given customer was down. That customer may have gone down, suddenly they're working again, nobody knows exactly why. And so there's now a temporal aspect to the digital twin where I can look back in time and I can understand what was existing in my network, a day ago, a week ago, because that network doesn't exist anymore, right? So that's another kind of virtual twin you can think of. A past state and a future state, and then in that past state, let's say there was a big surge of traffic in my network because Apple had a new OS version and everyone is downloading this OS version, and it swamped the network. Can I replicate that state from yesterday or last week and then change my network and make some updates to it and understand, well, if I had some additional nodes, if I had some additional fiber routes, if I change the IGP metrics in my network, whatever you want to change, would that have resolved that issue and given me a stronger network, right? So that's another way you could think of using a digital twin. And so along that pathway of kind of developing this kind of functionality, the first thing we look at is data inputs. What is required, available in the network that you can pull into this virtualized environment to build out that network view that you want to maintain. And so a lot of data sources, right? We have routing information, but that routing information could come from SNMP, it could come from peering with the network itself, it could come from protocols like MRT or other protocols where maybe a carrier has already collected that data and has it available. A lot of ways you can kind of gather that routing data. Then we have the transport topology that often comes from EMSs or NMSs. We have traffic engineering, configuration data. There's telemetry, network telemetry. Again, that could come directly from the network. It could come to us via Kafka from a different source. So lots of places we can get that data. We've also been, sort of on a side note, been doing some work in the auspices of the IETF around something called Yang push, where the carrier maintains a data mesh, receives a Yang formatted data from the network. That data is stored in that data mesh. There is a Confluent schema registry where the schema of that data is held, And then a company like Blue Planet can come in and say, oh, I see a data source is available. I can pull the schema of that data, and I can subscribe to that data, that Yang data that gets pushed from the data mesh to Blue Planet. And so you can maintain a single kind of common set of data that any observability or any other tool could use. It's just one more way we've seen people want to kind of pull data from the network and spread it out to their vendors in different ways. Once we have that data, then you want to model the data, and that becomes complicated because you have a multi-layer network. Often it's VPN services over an MPLS or an SR layer, over an IP layer, over a transport layer, and then you have for that entire stack all the telemetry, the performance data, the latency, the congestion, the traffic data from NetFlow or IPFix, for example. Kind of stacking all the data onto each other so you have a single coherent data model. And there really isn't sort of a commonly used data model for this kind of information in the industry. And so a lot of that comes to kind of developing that model so you have that consistency and you can understand then where is my IP traffic flowing at a given time. That's where that's going to depend on the routing path. And so you have to pull that NetFlow traffic and the IP traffic together and then understand which services are impacted, right? So, but once you have that kind of foundation of the collected data plus that common model, then you can start to build tools on top of it so people can actually make use of that. And so like a virtual change management tool, for example, right? Where I can, as I said, you can take this virtual data, this virtual representation of the network and start to manipulate it and say, okay, I want to have some more routers, I want to add more traffic, I want to take down some certain links, and I want to understand how all these changes in parallel impact the network. I might want to understand which failures in my network would be most damaging to my network and need to be sort of addressed, or which dual link failures across my entire network are going to black hole the most traffic or impact the most IP services, for example. And so those sorts of analyses can give you that visibility into where the weaknesses in your network exist today. We certainly see in some cases, there was one case I remember from a number of years ago where one carrier actually had two outages in the network that actually split their entire network in half because of the way things were designed. They thought they had more resiliency, but the result was that there was this weakness, and through using our tool, they were able to sort of identify ways they could rebuild the network to overcome that vulnerability. Other things here, multi-layer observability, right? Let's say we have optical link failures, and we want to understand, which VPN services are impacted by an optical link failure. That kind of information can be very interesting. Looking at SRLGs. SRLG is the optical layer or the IP layer. So all these sorts of information can then be understood and changed and manipulated to understand the impact on your network, or given a failure, if we had additional traffic, right, how would that be impacted? And so lots of different analyses you can do at this point. And then the next step, though, is this is all great, right? This is great for planning purposes, for an engineering team to understand this, but once we identify those improvements we can make to our network, what can we do with that data, right? Can we push, real-time updates that we find from our tool to our NOC, assurance tools, so that our NOC employees can understand, that information that we've seen on the IP side, on the IP virtual twin side. Can we identify that there are certain changes to IGP metrics or to RSV PTE or SR policies that we'd like to implement, and can we push those from the digital twin tool to the network automatically, right? So we start to create this kind of a closed loop response system to the conclusions we've come to from the digital twin side, and not have to take that data, put it in a spreadsheet, send it over to some operations team to then manually input, right? And so this whole concept of automation paired with that digital twin gives us a very powerful set of functions where you can understand what's going on, you can find out what the best recommended changes are, and then push those directly to the network in a single flow of automation. One thing I don't have listed on this slide, but for Ray's benefit, I'll talk about it now, is AI. So the reason I didn't put it in here is because from our perspective, AI isn't like a thing that sits to the side of your main tool, but rather it's something that embeds itself throughout all the components of your tool. You look for ways where you can use those techniques of machine learning or Gen AI or whatever it is, and improve what you're doing. And so, for example, multi-layer observability. You could think of in a multi-layer network, one of the gaps of knowledge is very often how the IP network connects to the optical network, right? So, by building out a machine learning model, you can start to understand what are the patterns, maybe from performance data, that can be used to create that correlation, right? So that's one area where we can leverage AI for the purposes of virtual twin. On the next slide, we talk about this a little more. Graph neural network, right? A network is really just a big graph. That's how you represent that data. And so thinking of a graph neural network as a technique to analyze your network, understand what optimizations you might be able to make. One area that we've sort of been looking into as well that seems interesting is IGP metrics. I mentioned that, which are still a very important tool in how you manage the flow of traffic across your network and how paths are routed across your network. And so looking at something like an IGP metric and what an optimized set of IGP metrics are to create a most optimal flow of data across your network. The same thing could apply to TE tunnels, for example, or SR policies, right? What set of policies or traffic engineering rules will give us the best spread of data across the network? Another common topic that people like to discuss these days is agentic AI. Can we create an agent that sits on top of that tool that allows us a new interface to start asking questions and querying and have more of an interactive session with the digital twin to be able to understand what it would take to achieve our objectives and not have to manually input that data. Likewise, APIs can also be used, right? So some people like to use the UI. Some people want to have that more interactive AI usage. Some people want to create offline that sort of bulk set of rules for their network and push those to us via REST or via Kafka. And so all those sorts of integrations are of interest here as well. But really, it's that idea that throughout this entire virtual twin, once you have that data, that very rich data set, you can start to apply new techniques to it. Because every time I talk to our data scientists, the first thing they say is, for us to do anything, we need data. Data is what we need for any kind of analysis we do. Here we have a massive amount of data. We have routing data, performance data, traffic data, all this data, in real time from a historical standpoint, and being able to pull all that together and then manipulate it is sort of a big playground for them to deploy new services and new analyses of our networks. Right. So just a couple final slides here, right? One is just a use case around failure analysis. I was talking about this, where you might want to go into the system and decide, okay, I want to look at different kinds of link failures at the optical layer, at the IP layer. I want to replicate those outages throughout the entire network in this virtualized environment, and then pull up a list of which pairs of outages have the most impact to our network. And understand, and then from that pathing, you can look at what services are riding over those, which services have the most customers impacted, or which paths have the most customers impacted when they do have an outage. And finally, investment analysis. We want to make an investment in a new set of core routers. We want to lease some new dark fiber and build some new core connections. How do we validate that those investments are going to give us the results we want, so that we can go to our management and say, hey, we really understand that these are going to improve the network in the ways we think, right? Again, take your network, build out some additional core links, rerun traffic across it, and then drill into very granular detail of, okay, which links had the most reduction in congestion, what traffic, rerouted or changed its base pathing based on that new core build. And that helps to validate that we are making the right investments, and we can move forward with that and get that approval. And so just a couple ways that we've seen a lot of customers use these digital twin systems. All right. That's it.